My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Operating Systems as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define an operating system. An operating system, OS, is the main software that controls a computer's hardware and helps users run programs. It acts like a manager or bridge between the user and the computer hardware. Without an OS, a computer is just a box of parts that cannot be used easily. The OS manages all basic tasks like starting the computer, running applications, saving files, and connecting devices like printers or USB drives. Examples: Windows, used in most PCs for personal and office work. Android, used in smartphones for apps, games, and calls. Linux, popular for servers and programming. In simple words, think of an OS like a traffic police controlling cars at a busy road. It makes sure everything runs smoothly without crashes. Similarly, the OS makes sure programs and devices work together properly. Next important short question is: 2. What is a shell in Unix? A shell in Unix is a program that takes commands from the user and tells the operating system what to do. It acts like a translator between you and the computer. When you type a command, like ls to list files, the shell reads it, understands it, and then tells the OS to execute it. Types of shells: Bourne shell, old and simple. Bash, born again shell, most popular, easy for beginners. C shell, CSH, useful for programmers. Example: if you type mkdir my folder, the shell tells the OS to create a folder named my folder. Easy way to remember. Think of the shell as a waiter in a restaurant. You, user, tell the waiter what you want, the waiter passes your order to the kitchen, OS, and brings back the result. Next important short question is: 3. Write any to process scheduling algorithms. To process scheduling algorithms: first come, first served, FCFS. This algorithm works like a queue in a shop. The first process that arrives is the first to get the CPU. It's easy to use but can make some processes wait longer, called the convoy effect. Example: if processes arrive as P1, takes 5 seconds, P2, 3 seconds, and P3, 2 seconds, the CPU runs them in this order, P1, P2, P3. Round robin, RR. In this method, each process gets a fixed time slice, quantum, to run. If a process isn't finished, it goes back in line, and the CPU gives time to the next process. Best for time-sharing systems like in computer labs. Example: if time slice is 2 seconds, CPU gives each process 2 seconds and keeps rotating, so no one waits too long. Easy trick. FCFS is equal to first come, first served like a queue. RR is equal to round robin like passing a ball in a circle. Next important short question is: 4. What is a multithreaded program? A multithreaded program is a program that can run multiple parts, threads, at the same time. A thread is like a small unit of a program that does a specific task. So, instead of running one task after another, a program can run many threads together, making it faster and more efficient. For example, imagine a web browser. One thread loads the page. Another plays a video. Another downloads a file. All these tasks happen at the same time without freezing the browser. Multithreading saves time and uses the CPU efficiently as it switches between threads quickly. It's like having many workers doing different jobs at once instead of one worker doing everything. Easy trick. Multi is equal to many, thread is equal to small tasks. Multithreading is equal to many small tasks working together in one program. Next important short question is 5. What is the use of the grep command? The grep command in Unix Linux is used to search for specific words or patterns in a file or text. It quickly finds matching lines and shows them, saving time when searching through large files. Think of grep like Ctrl+F on your computer. It highlights and shows where the word appears. Example: grep apple fruits.txt. This command will search for the word apple inside the file fruits.txt and display all lines containing it. Why it's useful? Saves time by quickly finding text in big files. Helps programmers search for code or errors. Can be combined with other commands for advanced searches. Memory trick. Grep is equal to global regular expression print globally find and print what you search for. So, grep is like your search engine inside the terminal. Next Unit 1. Long questions. First important long question is 1. Write short notes on Unix file system, commands, and shell programming. Short notes on Unix file system, commands, and shell programming. The Unix operating system is widely used for servers, programming, and system management because it is powerful, reliable, and simple. 3 important concepts in Unix are its file system, commands, and shell programming. 1. Unix file system. The Unix file system organizes data in a hierarchical, tree-like structure starting from a single root directory. Everything in Unix is treated as a file, whether it's a document, a program, or even hardware like printers and disks. Important directories. Home stores user files. Bin system commands. Etc. configuration files. TMP temporary files. Example: a file path home student notes.txt shows a file named notes.txt in the student's home folder. 2. Unix commands. Unix commands are short text instructions typed in the terminal to do tasks. Examples: ls lists files in a directory. cd folder name changes directory. cp file 1 file to copies files. rm file.txt deletes a file. These commands are powerful, and you can combine them to perform complex tasks quickly. 3. Shell programming. The shell is a program that takes user commands and communicates with the operating system. Shell programming or shell scripting is writing a series of commands in a file, script, to automate tasks. Example of a simple shell script: echo hello user. Date. This script prints a welcome message and shows the date. Shell scripts save time by running repetitive tasks automatically, like backups, system updates, and file management. Quick memory tip. File system is equal to a well-organized tree storing everything as files. Commands is equal to short instructions to work with files and processes. Shell scripting is equal to automating tasks like a digital assistant. Unix is popular among programmers and system admins because it is fast, secure, and easy to script. Next important short question is: to explain the structure of operating systems and various OS strategies. Structure of operating systems and various OS strategies. The operating system, OS, is software that acts as a bridge between the user and computer hardware. It manages memory, processes, files, and devices so users can work easily. To make this management efficient, the OS has a clear structure and uses strategies for better performance. Structure of operating systems. An OS is built in layers or modules, each handling a specific task. One hardware layer includes CPU, memory, and devices. 2. Kernel, the core part of the OS that controls hardware, manages memory, and schedules processes. 3. System programs, tools that provide basic functions like file handling and device drivers. 4. User interface, command line or graphical interface for users to interact. Example. In Windows, the Start menu and desktop are part of the UI, while memory management is handled deep in the kernel. Types of OS structures. Monolithic OS, all services, file system, drivers, etc. run together in one large program. Example, MS-DOS, early Unix. Layered OS, built in layers, each layer talks only to the layer below. Example, the operating system. Microkernel OS, only essential functions are in the kernel, others run as separate modules. Example, macOS, Windows NT. Modular OS combines monolithic and microkernel approaches for flexibility. Example, Linux. OS strategies. To keep the computer fast and secure, OSs follow these strategies. 1. Multiprogramming runs many programs at the same time by sharing CPU. 2. Time sharing gives each user a small slice of CPU time for multitasking. 3. Virtual memory uses hard disk space to extend RAM. 4. Caching stores frequently used data in fast memory for quick access. 5. Spooling queues print jobs or slow device tasks for smooth execution. Example, in a cyber cafe, many users share the same computer server using time sharing. Quick memory tip. Structure is equal to layers, hardware kernel programs UI. Strategies is equal to tricks like multiprogramming and virtual memory to keep systems fast and efficient. Next important long question is 3. Discuss process states and process scheduling in detail. Process states and process scheduling. A process is a program in execution. The operating system, OS, manages multiple processes so that the CPU is used efficiently. To do this, the OS keeps track of each process's state and uses scheduling to decide which process runs next. Process states. A process goes through different states during its life cycle. 1. New, the process is being created. 2. Ready, the process is ready to run but waiting for the CPU. 3. Running, the CPU is executing the process. 4. Waiting, blocked, the process is paused because it's waiting for input-output, I/O, or some event. 5. Terminated, the process has finished execution. Example, if you print a document, the printing task moves from ready running waiting for printer terminated once done. Process scheduling. Since many processes need the CPU, the OS uses process scheduling to decide who gets the CPU next. The scheduler is like a traffic controller for processes. Types of scheduling. 1. Long-term scheduling. Decides which jobs enter the system for processing. Controls job mix, CPU-heavy or I/O-heavy tasks. 2. Medium-term scheduling. Temporarily suspends or resumes processes to balance system load. 3. Short-term scheduling. Chooses which ready process gets the CPU next. Happens frequently, in milliseconds. Common scheduling algorithms. 1. First come, first served, FCFS. Processes run in the order they arrive. Example, like standing in a queue at a railway ticket counter. 2. Shortest job next, SJN. Runs the shortest job first. Saves time but needs knowledge of job length. 3. Round robin, RR. Each process gets equal time quantum. Example, like giving each cricket player a turn to bat for a fixed number of balls. Quick tip to remember. States, new ready running waiting terminated. Scheduling decides who runs next to keep CPU busy. This makes computers faster, fairer, and efficient. Next important long question is 4. Explain process synchronization and its mechanisms. Process synchronization and its mechanisms. In an operating system, many processes often share resources like printers, memory, or files. If two or more processes try to access these resources at the same time, errors can happen. This is called a race condition. Process synchronization is the method used to coordinate processes so they run safely without interfering with each other. Why is it needed? To avoid data inconsistency, incorrect results. To make sure only one process uses a resource at a time. To keep the system safe and efficient. Example, imagine two people withdrawing money from the same bank account at the same time using two ATMs. Without synchronization, both might withdraw 500 rupees each from a 700 rupee balance, which is wrong. Synchronization ensures this doesn't happen. Mechanisms of process synchronization. 1. Critical section. A critical section is a part of the program where shared resources are accessed. Rule: only one process can be in its critical section at a time. 2. Mutex, mutual exclusion object. Acts like a lock on a door. A process must lock the resource before entering the critical section and unlock it after use. Example, like one person locking a washroom door before use. 3. Semaphores. A counter that controls access to shared resources. Types. Binary semaphore, only two values, 0 or 1, works like a mutex. Counting semaphore allows a fixed number of processes to access a resource. Example, a parking lot with 10 spaces allows only 10 cars at a time. 4. Monitors. A high-level synchronization tool that automatically handles locks and conditions. Easier for programmers to use. Quick memory tip. Think MSM for synchronization tools. Mutex lock and unlock. Semaphores count resources. Monitors automatic control. In short, process synchronization prevents conflicts, ensures safe execution, and keeps data consistent when processes share resources. Next important long question is 5. Describe deadlocks. Explain necessary conditions and methods to handle deadlocks. Deadlocks, meaning, conditions, and handling methods. A deadlock in an operating system happens when two or more processes are stuck forever, waiting for each other's resources, and none of them can continue. Example, imagine two friends. Asha has a pen but needs a notebook from Ravi. Ravi has a notebook but needs Asha's pen. Both are waiting for each other to give the item first, so no one moves forward. This is a deadlock. Necessary conditions for deadlock. A deadlock happens only if these four conditions are true at the same time. Remember MNHC. 1. Mutual exclusion, M. A resource can only be used by one process at a time. 2. No preemption, N. A resource can't be forcibly taken away, it must be released voluntarily. 3. Hold and wait, H. A process is holding one resource and waiting for another. 4. Circular wait, C. A circular chain forms where each process waits for a resource held by another process. Methods to handle deadlocks. 1. Deadlock prevention. Design the system so that one of the four conditions never happens. Example, don't allow circular waiting by giving resources a fixed order. 2. Deadlock avoidance. The system checks before allocating resources to make sure a safe state is maintained. Banker's algorithm is used here. Example, like a banker ensuring loans are given only if repayment is guaranteed. 3. Deadlock detection and recovery. Allow deadlocks to happen but use an algorithm to detect them and then recover. Recovery methods kill one or more processes or take resources back. 4. Ignore deadlocks, ostrich method. In some systems, like small PCs, deadlocks are rare, so they are ignored. Memory tip. Think of PNDR prevention, avoidance, detection and recovery for deadlock handling. In short, deadlocks are like a traffic jam at a four-way crossing where no car moves. By preventing, avoiding, or detecting deadlocks, OS ensures smooth process execution.